All right, for homework tonight, we're going to do a review of all types of simplifying radicals. So make sure that if I write it, you write it. So you should be writing this in your notebook. All right, so we're going to start by simplifying a square root. In this case, the square root of 98. So remember to do this, we use our upside down division. Start with 98, and we're looking for prime numbers, okay? Prime numbers. Some of us are forgetting that, and you're starting to use numbers that are other than prime numbers. So 98 is an even number. When in doubt, it can be divisible by 2. So let's do that. 98 divided by 2, and you should get 49. All right, so 98 divided by 2 gives us 49. 49 may look like a prime number, but it's actually a perfect square. 49 is divisible by 7. 49 divided by 7 leaves us with 7. 7 is a prime number. We can divide that by itself, and we're left with 1. Remember, we always want to be left with 1. Now we have our prime factors, 2, 7, and 7. Since we're looking for a square root, we're looking for groups of 2. So I have 2 7s. That means that I'm going to bring a 7 down to the outside of our radical symbol. There's nothing in front of the original radical, so nothing else goes in front except for 7. And then whatever's left over, that 2, that's what's going to be left on the inside. So our final answer is 7 root 2 for the square root of 98. Excellent. Okay, so let's see what happens when we have a square root with a number in front with a coefficient. So in this case, 4 square root of 192. All right, so this number out in front, 4, that's going to be important, and it's going to end up at the end of our simplified number, so we're just going to kind of think about that for a little bit. We're going to take our 192, and we're going to do our upside down division. Now I brought my calculator up, 192, and again, it's an even number, so we can divide that by 2. So in our calculator, 192 divided by 2 is going to give us 96. Okay. 96 again is an even number, so that's divisible by 2. 96 divided by 2. We get 48. We could keep dividing that by 2. Hopefully we don't need a calculator, but it's always good to check. Divide by 2, we should get 24. 24 is also even. Divided by 2 again, we get 12. Divide that by 2, we get 6. Divide that by 2 again, we get 3. And we're left with 3. Divided by 3 is 1. Okay, so that 1 means that we are finally done with all of our prime factors. There's a bunch of 2's. All right, so let's look for groups. I've got a group of 2 there, so that means we're going to bring a 2 down. I've got another group of 2, so that means we'll bring that 2 down as well. And we're separating these numbers by multiplication. Another group of 2, so another 2 comes down. And then don't forget, we started with a 4 on the outside of our radical. That 4 comes all the way down, and it's going to multiply these coefficients. So we have 4 times 2 times 2 times 2. Then we're left with a 3 to go inside the radical. Now we definitely can't leave our answer like this. We need to simplify. 4 times 2 times 2 times 2. So go ahead and try that and see what you get. So hopefully you got 32 root 3, and that is our final answer for this. We haven't seen cube roots for a while, so let's see an example of a cube root. Okay. So in this case, let's do the cube root of 40. So the cube root of 40. Okay. So this process is going to be very similar, but now we're looking for groups of 3 prime factors. So we have our upside down division. 40 is divisible by 2, and we get 20. That's also divisible by 2, and we get 10. Divide that by 2, we get 5. And then 5 divided by 5 is 1, and we want to end with a 1. Excellent. Here are our prime factors, 2, 2, 2, and 5. Now be careful. This is a cube root. So we're not looking for groups of 2, we're looking for groups of 3, and that's told to us by that index 3. So I do have 3 2's. I bring one representative down as our coefficient outside of the radical. I have a cube root, so don't forget to write that little 3 for the index. And all that's left is a 5. So our final answer should be 2 cube root of 5. The next thing we did with radicals was we multiplied them. So we're going to practice multiplying radicals. We're practicing these all together because your concept test is going to include simplifying, multiplying, and adding and subtracting. Okay. So let's start with, let's see. I want to give you an example that both have coefficients. All right, so let's start with this example. We have 2 root 35 times 3 root 10. Okay, so our first step is we multiply the coefficients. So I'm just going to put a little times instead of writing multiply. We multiply the coefficients. Okay, so that's our 2 and our 3. So 2 times 3 gives us 6. Our second step, after we multiply the coefficients, we're going to multiply the radicands. So step 2, multiply radicands. And those are those numbers underneath the radical symbol. So square root of 350. All right. Our last step is to simplify. So this is where we do what we've been doing this whole time. It's just simplifying, okay? So I'm starting with 6 square root of 350. And I'm going to do my upside down division with the radical. So 350, upside down division. This 6 is definitely going to be important in the end. So we're just going to keep that in mind. It's going to come down eventually. All right, let's do some division. So 350. Now, a lot of people see 350 and they think, oh, I want to divide that by 10. While 350 is divisible by 10, 10 is not a prime number. So instead, if something ends in a 0 or a 5, we can always divide it by 5. So let's try that. 350 divided by 5. And that gives us 70. 70 again is divisible by 5. That gives us 14. 14 is divisible by 2. That leaves us with 7. And then 7 is divisible by 7. 7 is a prime number. And that leaves us with a remaining number of 1, which is what we always want. All right, so our prime factors are 5, 5, 2, and 7. Let's look at our groups. This is a square root, so I'm looking for groups of 2 of the same number. I have 2 5s, so a 5 comes down as a coefficient. Don't forget about that 6 up there. That 6 is going to come down. Okay. 2 and 7 don't match up with any other numbers, so they stay inside the radical. So they stay as a radicand. But we're not just going to leave them as 2 times 7. We need to simplify them. So we're left with 30 square root 14. So again, when you're multiplying radicals, think about these 3 steps. Multiply the coefficients, multiply the radicands, and then simplify. And look back at these notes to see if you're doing all of those steps. All right, we're going to move on to adding and subtracting radicals. Again, we're going through each of these because adding and subtracting is a slightly different process than multiplying. So it's important that you understand how to do each of them. Right? So let's try this. I have 3 root 6 plus 3 root 54. Okay. Our step 1 is we need to check the radicands. Check the radicands. Okay. So I have a 6 and I have a 54. Are they the same? No, they're not the same. Our goal is to make them the same. So in order to do that, we're going to have to simplify. So simplify each. Okay, simplify each term. So we're not combining the coefficients and the radicands like we did for multiplying. We have to simplify them separately. So I'm going to look at them completely separately. I've got 3 root 6 to start with. All right. So let's look at 6 with upside down division. 6 is divisible by 3, which leaves us with 2. 2 is divisible by 2, which leaves us with 1. Okay. 6 only has prime factors of 3 and 2. Those can't be grouped at all, so this really cannot be simplified. So all it means is that 3 root 6 stays the same. All right. Now let's move on to 3 root 54. Now 54 is a larger number, so I'm guessing that we're going to be able to simplify this. If you're not sure, get your calculator out, and we're starting with the number 54. It's an even number. I want to divide it by a prime number, so when in doubt, divide by 2. All right, that leaves me with 27. 27 is not even, but it is divisible by 3. So 27 divided by 3. That leaves us with 9. That's divisible by 3. 27 divided by 9 is 3. 9 divided by 3 is 3. Divide that by 3 and we're left with 1. So let's take a look at our prime factors. 2, 3, 3, and 3. We're looking for groups of 2. There's a group of 2 3s, right? But don't forget, we started with a 3 in the coefficient originally. So that 3 is not lost. That 3 comes down. Then this 3 representing the group comes down, separated by multiplication. And let's check what's left on the inside of the radical symbol. A 2 and a 3. So 2 times 3. So simplified, this is 9 root 6. 3 root 6 from the beginning didn't change. And there was a plus sign in between them. Okay. So now that we have the same radicands, we're going to keep the radicand. We're going to keep it, all right? So that root 6, it stays. Unlike the last time when we were multiplying, we're not multiplying them, they just stay. Stays the same. This is our like term, okay? So keep like radicand. That's the radicand that's repeated. In this case, root 6. Okay. Once we have that, then we can just simplify the coefficients. So we have a 3 plus 9. We're just going to simplify that. 3 plus 9 leaves us with what? 12. So keep like radicand, then simplify the coefficients. All right. So our final answer is 12 root 6. Okay. I hope that helps. Make sure you're referencing your notes as you're doing your homework tonight and paying close attention to see if you're adding, subtracting radicals, multiplying radicals, or just simplifying them from a single radical.